So for lesson 68, we're looking at finding conditional probability. It is probability. It's kind of day 2 or 3 with it, and we're looking at different ways that we can go about assessing these groups or these sample spaces. Dependent events, you can put this in your notes if you'd like. And it's simply stating that if A and B are dependent events, then probability of A and B is equal to the probability of A times the probability of B given the A part. This is the new part of today's lesson, is this vertical line in our notation. And again, it means given. So it's what we already know. Probably the best example that I can come up with is, I can tell you within the classroom we have a mole. Okay, one of you is the mole. Has anybody seen that TV show? Okay, one of you is the outsider. Now, if we were to try to find that mole, what would be the probability of just random of picking that mole? If we knew it was one of you students, excluding myself.
1 in 30 something.
1 and we do not have, I think we're right at 24 today for 1 out of 24, right? That's if we had the total population, 1 out of 24. Now, I'm going to give you the given part. It is given that the mole is in somewhere in Sydney's row. Now, what's the probability of finding the mole? 1 out of 5, right? So that's the given stipulation part of it, is if it's given, essentially what we're doing is we are narrowing down our total population and just looking at a specific category. Okay? Again, keep that definition in your notes. Example number 1. Suppose we have the 2 spinners, 1, 2, 3, and 4. We want to find the probability that the first spinner lands on 2, and the sum of the spinners is going to be 6. Chart is going to be very helpful for this one because we do have our 2 events. So we have our top column and our bottom column. Notation, probability of 2, and that sum being 6. That's what we're looking for. Per the definition, if we go back to it, that is equal to the probability of the first event, which we said was getting 2. And then we're going to times that by the probability of getting a sum of 6, given that we already had 2 at the beginning. I know this notation looks a little messy, but once we get into the chart, I think you'll find it easier than what it is. So let's go ahead and start building this chart. You know, if we're going to spin the spinner once, what are the choices that we could get? What are the outcomes? Possible outcomes. Well, 1, 2, and 3, right? As well as 4. Those are the outcomes that we could get on that first spin. And now we spun it once. We got 1, 2, 3, or 4. And now we're going to spin it again. Options that we could get on the second spinner are again going to be 1, 2, 3, and 4. So 2 events, we have our top row, we have our column. Which is now going to create our sample space, the list of all possible outcomes. If we got a 1 first, we get 1, 1, then 1, 2, 1, 3, 1, 4. So there's our list. Now let's just start with the first probability. If we move this over here, what was the probability of getting 2 on the first spin? Thank you. 1/4. We only had 4 sectors, 2 out of one of those 4. Okay, so that's the easy part. But understand, as we move on to the second event, we have to know that I had a 2 on the first one. So while I have all of these originally, if I got a 2 on the first spin, what it does is it eliminates this column, it eliminates the 3 column, and it eliminates the 4 column. So the only ones that we have to look at now are the ones that occur in this one. And now if we go on to the last one, for the second event, we want the sum of these 2 spins to add up to 6. So if we look at this, 2 and 1, will that get us a sum? Nope. 2 and 2 will get us 4. 2 and 3 will get us 5. And 2 and 4, sure enough, that's the only one that'll get us a sum of 6. So what's our probability of getting a sum of 6 given that we had to get 2 on the first one? Well, how many total options did we have? We had 4, and only one of them. Multiply them together. (1/16). Let's do one more very similar to it. Again, we have our 2 spinners, 1 through 4. Find the probability that the first spinner lands on an odd number and that the sum of the spinners is going to be greater than 4. Notation, first one we want an odd number, and the fact that the sum is greater than 4. So per the definition, we're going to start by finding the probability of the first event. And then we're going to take it times the probability of getting a sum greater than 4, given that the first spin was an odd number. Let's go ahead and start by creating our sample space again. It takes a little bit of time to set up, but trust me, you will need it for some of these problems. We said on the first one we want to get that probability of odd. So the probability of getting odd on the first spin, 2 out of 4, 1/2. And now in order to get the second one, to get that sum to be greater than 4, I know that the first spin either had to be the 1s or it had to be the 3s. And again, the reason is because it's an and situation. We want the first event to happen as well as the second event. So essentially what we can do is we can eliminate all of these. Going back to the mole example, we crossed out this row, and this row, as well as Dalton's row and Allie's row. Okay, leaving us with just these 2. And now we go through this list and we identify the sum that's greater than 4. Top left corner, this is a no. 1 and 2 is no. 1 and 3 get us a sum greater than 4. Close, but it's not greater than. So 1 and 4, that one will work. 3 and 1, again, close, but not close enough. 3 and 2 will work, 3 and 3, and 3 and 4 will. What was our total here? Not 16, but 8. We had 8 available options to us, and we found that 4 of them are available. So 1/2 times 1/2, 1/4. Charts are going to be very, very helpful. Okay, if you have highlighters, you can use those as well. Otherwise, just simply crossing out the other columns works too. The other way we can work with conditional probability is looking at the charts themselves that they give us. The table shows the results of the survey that asked students to state the year and season of their birthday. So we have the years 1992, 1993, and 1994. They want us to find the probability of winter given that it was the year 1993. It's given that it's the year 1993, correct? Therefore, I could care less what 92 or 94 has for us. So what we can do is we can go ahead and just eliminate those. So while the total population started out being all of these, all 12 categories or entries, now we're down to just those 4. And the one that we're looking at is the winner within that year. So if we add up 16, 9, 11, and 9, numerator is what we want. We want to know the probability of getting winner. 16 over 45. Basically 36%. Get the idea? You cross out all of the other options that are not possible to us. And for the last one, we're going to find the probability of 1992, once again, given that it's spring or summer. So now it's just kind of the other way. It's given the season. It's given that it's spring or summer. So it could be this one. It could be this one, which means we can eliminate those. And we can also eliminate those. We want to know the year of 1992. It could be in this season or it could be in that one. So as we go to set up our fraction, 6 and 12 will be our numerator, and all of the other entries will be our denominator. Cross out the ones that are not given to you. Okay? We know it occurred in this row, so we are not concerned about anybody else. Hence the reason why we call it conditional probability. Let's do practice problems A through D.